something on your test and you're not sure if it's true or not, please don't just write the statement because you could get it wrong. Put a question mark. Okay, put a question mark. Then when the reader reads it, they're just saying, oh, you're questioning if it's true or not. Okay? Then look at your function and say, is this function continuous? Yes, polynomials, guys, are always continuous. Okay? So then you could write over here, put yes. Okay, answer your question though. And then ask yourself, are polynomials also differentiable? Well, it actually depends on the polynomial. So let me just tell you, this one is. So you would say yes. If you graph this, it would look something like this. Do you guys remember that from some point in your life? Okay? Yeah. All right. So guys, when these two conditions apply, then you can apply MVT. What does MVT mean? It means there's at least one point. Find that point C is what it says. Find that point C on this interval where this is true. So guys, you need to memorize this formula. And this formula, I would definitely test you on the formula quiz, okay? You need to memorize this formula. You need to be able to write it. If I say, what's the conclusion of MVT? This is what MVT concludes. If this is true, if the function is continuous, if this is true, if the function is differentiable, then the condition is true, okay? Oh, these are the conditions, sorry. This is the conclusion, and then the conclusion is true, okay? So how do I plug into the conclusion? Make sure you understand, though, MVT says there is at least one point where this is true. It's not always true. It's only true at one or a few more points, okay, but not at all the points unless you have a straight line. Okay, you guys can think about that for a while. But this is true at what point? Well, let me figure out what point. Well, I'm trying to solve for C, okay. What is my B in this problem? 1. Okay, what's my A in this problem? -1. Is everybody good with that? So this B minus A here is 1 minus -1. You guys okay with the minus? You're good? Okay. So then what you're going to do is you're going to go to the side of your paper and you're going to figure out what is f of 1. Okay, because that's what I'm trying to plug in. What is f of 1? So here's f. Everywhere there's an x, I'm going to put in what? 1. So this will be 1 minus 1 minus 2. Which I think is -2. Please check me on that. Okay. Then I'm going to plug in -1. So here's my f. Everywhere there's an x now, I'm going to put in -1. So this will be -1 minus +1 plus 2, and that's going to be 0. Then I plug into the conclusion of the mean value theorem. Okay. The conclusion of the mean value theorem said, if I take the derivative of x, of f of x, can I just go ahead and take the derivative here? Are you guys okay with that? Yeah. If I take the derivative of that, do you see it's 3x squared minus 2x minus 2? Is everybody good on that? Okay, that's the derivative of x. I'm sorry, the derivative of f, okay? Then I'm going to plug into the right side, and the right side says f of 1 is -2 minus f of -1, which is 0, over 1 minus -1, which is 2. And what is -2 divided by 2? -1. And students are so happy that they figured out the average rate of change that they write down the answer as -1. What is wrong with that?
It's wrong.
It's wrong. Why is it wrong, though? Isn't that the answer? Look, I solved, I got the answer. I plugged it into the equation, I got the answer. You still have the x values here. Guys, the question is, find the x value where this is true. Find the x value where the slope of the tangent line is equal to the slope of the secant line, okay? So guys, your goal is not to find the slope of the secant line. Your goal is to solve this equation, okay? So make sure you understand what we're trying to get at here. And if I solve this equation, any suggestions on how to do this? No, you won't have a calculator on this test, so that is not a good suggestion, okay? You're going to go ahead and make it into a quadratic. You guys good? And then you're going to have to factor this and set it equal to 0. Guys, some of you guys are having trouble factoring when this is not a 1, okay? If you are having trouble factoring when this is not a 1, go find an Algebra 1 friend, okay? Ask them to help you out. You need to be able to do this, okay? I'm joking about that, but there's plenty of stuff online that will help you do this, okay? Khan Academy will help you do this. This is something you need to know how to do. It's something I assume that you can do quickly. If you're spending 10 minutes on this on the exam, okay, that's a problem. You should just skip it and go on to something else, okay? So this, guys, is going to be 3x times x what makes you give a multiple of 1, factors of 1 are going to be 1 and 1. Then I need to figure out how do I get negative 2x? What signs can I put in to get negative 2x? And I'm looking, and I think I'm getting something like this. And if someone can check me on that, my signs, that's what I'm getting, okay? Then you solve for x, and so what you get is if something times something is equal to 0, what happens is one of these somethings must be 0. So that means 3x plus 1 is equal to 0, which will give me x is equal to negative 1/3, or x minus 1 is equal to 0, which will give me x equals 1. Okay, now here's the careful part you need to be careful of. These numbers, if you tell me they're the answers, they need to be inside the interval, okay, inside. They actually cannot be outside the interval, for sure, but they actually cannot be part of the interval either, okay? Because if you look at mean value theorem, let me just show you the mean value theorem. If you look at mean value theorem says that there is at least one number that's key that's like inside the interval. Okay, does that make sense? It's not at the intervals. Okay, so if you look at the numbers, how do I get back? Okay, here you go. If you look at the numbers I have the answer is negative 1 and 1. Okay, guys, what is my interval in this problem? Negative 1 and 1. So I cannot count what? I cannot count the 1. So my answer for this would be x equals negative 1/3, or you could say c is equal to negative 1/3. That's a good answer too, because they asked you to find the c. The c is just an x value where this is true. Okay. Any questions on this problem? Okay, you had a homework problem similar to that, and I wrote down the answer, so hopefully you understand. Don't count any numbers that you get that are on the interval or outside the interval. All right. Guys, that doesn't mean that that doesn't mean that the slope of the secant line is not equal to the slope of the tangent line on the interval, on the endpoint. It just means that MVT doesn't guarantee it. Okay, it doesn't guarantee it, so you can't say it's guaranteed. It might be true, that might be true, but it's not guaranteed. So for this problem, you just can't guarantee it. Okay, I had some questions about what graphs do I need to be able to graph? What functions do I need to be able to graph? And so I have some help up here about what you guys need to graph. If you need to know that these functions are continuous or differentiable. So let's look at x cubed. Guys, you need to know that x cubed looks like this. You guys remember that from your parent functions? You also need to know, while we're talking about it, that the root, like the cubed root, okay? So this is actually the cube root of x, looks like this, okay? And the most important things that you need to know about these two functions actually is that there is a horizontal tangent line right here for this function. Okay, why is there a horizontal tangent line? Because if this is f, and I take the derivative of f, if I plug in 0 here, what's my slope? What's my slope right here at 0? F prime at 0 is going to be 3 times 0, which is 0. Okay, if your slope is 0, you're going to have a relative max, a relative min, or a horizontal tangent line. How do you know that? Because slope of 0, superhero, relative max, relative min, horizontal tangent line. Okay, I'll be the first to admit I'm not a good horizontal tangent line. Okay, but here's the thing you need to know. If you have a slope of 0, it's going to be a relative max, a relative min, or a horizontal tangent line, but all of those have slopes of zeros. Guys, what does that mean about the derivative? Does it still exist? Yes, it still exists, okay? It does still exist. Where the derivative doesn't exist is right here. Right here, what you have is what we call a vertical tangent line, okay? Not the same thing, not to be confused with the vertical horizontal tangent line, okay? At a vertical tangent line, does a derivative exist? No. Why not? Because I'm like you and you're like me. No differentiability. Sharp turn. Vertical tangent. Any discontinuity. And what are the discontinuities? Joyful. Okay? So all of those guys, if you have them, you're going to have no differentiability. So guys, what we're concerned about is there differentiability between 0 and 1 on this function? So between 0 and 1, okay, so let me show you 0. Here's 0. Oops, is that right? Here's 0 and here's 1. Okay. Question, is the function continuous between 0 and 1? Yes. Question, is the function differentiable between 0 and 1? And remember, you don't have to worry about the endpoints, right, on differentiability, okay? But the truth is, this was differentiable anyway, but you don't have to worry about the endpoint. So is the function differentiable between 0 and 1? Yes. So MDT applies here between 0 and 1. Does that make sense? Look at this picture, guys. Okay, this picture, later on I ask you about it, but let me just go ahead and ask you about it now. Okay, for this function right here, for the cube root of x between negative 1 and 1, tell me if MDT applies. So let me graph this for you. Okay, this is the cube root function. Make sure you can actually graph that. Okay, between negative 1 and 1. Tell me, guys, is the function continuous between negative 1 and 1?
Yeah.
Is it differentiable between negative 1 and 1?
No.
No. Very good. Why not? Vertical tangent line. If you had this as an MVT problem on your test, okay, what I would like you to do is say the function is not differentiable on, make sure you do open parentheses because that's MVT. Then you'd write, therefore, MVT does not apply. And you would take your pencil and you would calmly move to the next question on your test. Does that make sense? You would not actually plug in MVT, right? Because it doesn't apply. The conditions didn't apply. You cannot implement MVT. You guys good with that? I can't tell you how many students on their test, they spend 10 minutes doing MVT on this problem, okay? When you really just wasted 10 minutes of your life, okay? And all you had to do is say it didn't apply. Yes, Brent?
Is that only when zero's on the interval?
That's only when zero's on the interval. That's, yes, for this problem, yes.
Okay.
For this problem, yes. Okay, so if you change this interval to 2, 5, now does MVT apply? Let's look at it. If I went from 2 to 5, okay, this part here, is it continuous?
Yeah.
Is it differentiable?
Yeah.
Yes. In this one, MVT would apply. You'd have to actually do the whole MVT thing. Okay, yeah.
If the interval were a 0, 1, could you do it because 0 is not on the open?
Good question. Okay, so if the interval here is 0, let's say 0 to 2, okay, you could still do it because you don't have to count the endpoints. That's a great question. So it would still, MVT would still apply if you were in 0, 2. Okay, good question. All right, let's look at another function that you have to be able to graph. Are you comfortable graphing the absolute value of x minus 2?
Yes.
Good, okay. See if this makes sense to you, though. What you would do is, you know the parent function. You know what y equals absolute value of x is, right? What's that parent function?
Right there.
Okay, how much is it shifted over? 2 to the right, okay? So this will be 2 here. And guys, here's a question. Look from 0 to 3. So this is where I'm looking, from 0 to 3. Do I have continuity?
Yes.
Yes. Do I have differentiability? No. Why not? Sharp turn. Okay. But make sure you understand, MVT doesn't talk about sharp turns. It talks about differentiability. Okay. So on your test, you would write the function is not differentiable on, and make sure you have an open circle. I mean, open, what do you call it, interval. Does that make sense? And then you'd say, therefore, MVT does not apply. And then you would calmly take your pencil and move to the next problem on the test. You guys good with that? If MVT does apply, if the function is continuous and differentiable, then you need to actually apply the test, okay, which is what we did on our warm-up already. All right, so this is a good question here, and this is kind of like what David was alluding to before. If I have a function that's x minus 1, okay, that you agree the parent function is absolute value of x, right? What's going to be the graph? Shift to the right one, right? Right, shift it to the right one, okay? So this is at 1, do you agree with that, the sharp turn? All right, if I'm looking at 2 to 5, so I'm looking at 2 to 5, would MVT apply for this graph?
Yeah.
Yes, okay, no sharp turn between 2 to 5. Do you see that? So is the function continuous between 2 to 5? Yes. Is the function differential between 2 to 5? Yes. And actually, I can look at this picture and say, because it's a straight line, do you see that the slope of the tangent line is going to be equal to the slope of the secant line at every single point? I don't know if you see that. Okay, so when you have a straight line, the slope of the secant line and the slope of the tangent line is equal at every single point. So the value for your C, and I don't think I would ask you this question, I've never seen a question like this, but they could ask you, the value of C would be all the numbers between 2 and 5, every single number, okay, all the fractions and everything, okay? All right, and here's another function that I expect you to understand how to graph. 1 over x minus 1, this one right here. You guys remember what the parent function is? It's the 1 over x parent function. So you guys agree that this is the parent function, 1 over x. Or maybe you're learning it for the first time. It's okay. This is 1 over x. Which way am I shifting it?
To the right.
By how much? 1. Okay, so I'm going to pull this to the right by 1. So that means this number here, it used to be at 0, the asymptote, right? Oops. So now it's at, not 0, sorry. So now it's at what? 1. Okay. All right, here's the question. Is this function continuous on negative 1 to 1? Okay, so here's negative 1 to 1. Is this function continuous? Oh, wait, something, is that right? Oh, I went to the wrong, okay, I'm sorry. I'm looking at this one up here. So not negative 1 to 1, negative 1 to 3. Okay, so from negative 1 to 3, is the function continuous? No. Okay, so what would I write if this were an MBT problem? I would write the function is not continuous on, and then close interval, right? So therefore, MBT doesn't apply. Would it be correct to say the function is not differentiable either? Is the function differentiable here? What do I have? Sharp, turn, vertical, tangent, any discontinuity. What are the discontinuities? Jump, crazy oscillation, infinite asymptote, infinity. This is an infinite asymptote. It's a vertical asymptote, okay? So you could also say the function is not differentiable because of vertical asymptote. So not differentiable on, make sure you do open parentheses if you say that. And then you'd say MBT doesn't apply.
So do you not have to say why it's not differentiable?
No, you don't have to say why. I actually just want you to say it's not continuous or not differentiable. If you say why, I would just be like, oh man, she's so smart. Like that's all I would think. Okay. All right. Guys, here's some more functions that you need to know if they're continuous or differentiable. Do you know e to the x? Can you draw it?
Yes.
Always continuous, always differentiable on all reals. Okay, for all of its domain. What about ln of x?
Yes.
Yes, it's actually always continuous and always differentiable on its domain. Okay, its domain is x is greater than 0. Okay, we're mostly just looking at its domain. Okay, what about this one over here? You have this for homework. Sine x plus cosine 2x. Is it continuous? It actually is. If you have a function that's continuous and you add it to a function that's continuous, right? Sine x looks like this, cosine x looks like this. You add them together, it's still continuous. Okay. The differentiability, I want to say it's a little bit more difficult, but just FYI, for your homework, it was differentiable, okay? I guess you had a calculator too. I won't do a hard one like this one. You do need to know it's continuous, but whether it's differentiable or not, that's a little bit tougher for sine and cosine, okay? Okay, so we covered what functions you need to know. We covered this, so I'll leave this online. And you guys go ahead and pass up your warm-ups, okay? And at this point, let me go ahead and do a problem. Do a problem that is similar to a test question. Okay, so you have a test question that looks similar to this. And this was your homework 2 nights ago anyway. Okay, so we need to know how to do absolute mins and absolute maxes. All right, and we use what's called a candidates test to do this. Okay, not to be confused what we're going to do today. Today we're going to do what's called the first derivative test. Okay, which is similar but not the same. Okay, but before to find absolute max and min, you did what's called the candidates test. Guys, how do you know you're trying to find the absolute max and min? Because it says, what if I wrote this on your test? What if I said find the max extremum? Same thing. You guys good with that? What if I said find the extrema? What am I saying if I say find the extrema? Max and min. Are you guys good with that? So know your vocabulary, okay? And how do you find the absolute max and min? Well, guys, honestly, on your test, if you don't know anything, please just go ahead and take the derivative. Okay, you're going to get some partial credit for that, all right? All right, then what you're going to do is you're going to set that equal to 0, and you're going to set that equal to d and e. Okay, what does this help you find? This is something you need to know for your formula quiz. What does it help you find? Your what points? Your critical points. You need to know that if you are trying to find critical points on your formula quiz, you need to know that that means f prime is equal to 0 or f prime is equal to d and e. That's a definition of critical points. okay? And to find my critical points, what I'm going to do is solve for x on this side. When I solve for x, I get x is equal to plus or minus 2. Do you agree with that? Okay? On the right side, when I solve for x, if you don't have any fractions, now be careful. If you have a negative exponent, then you do have fractions, okay? But if you don't have any fractions, what always happens is you end up with 1 is equal to 0, okay? Which is no critical points. You don't get any critical points from that result. Then, if I'm trying to find absolute maximum and min, I take all my critical points, and what do I do with them? I bring them into a candidates test, okay? Your candidates test, guys, becomes what they call the justification. So when they say, find your absolute maximum min and justify it, if your candidates test is correct, your justification is correct. If your candidates test is done incorrectly, your justification is incorrect, okay? I'm going to come over here, I'm going to put all of my critical points in, but what else do I put in into my candidates test? My endpoints. So what are the endpoints here? And you put them in order, okay? So my endpoints are 0 and 4, and do you see they kind of flank the 2 here, okay? And the question is, give me all the max and min values between 0 and 4. So if I get a critical point that is outside 0 and 4, I don't have to put it in the candidates test. You guys good with that? Or you can put it in the candidates test and just cross it out. Because if you actually calculate this, and this becomes one of your highest or lowest numbers, you will not have found a min or max inside the interval. Does that make sense? You found a min or max outside the interval, and that's not what they asked you for. Okay? After you do that, what you're going to do is you're going to plug into the candidates test and find your largest number and your smallest number for y. Okay, so let's go ahead and plug into this candidates test. Again, you don't have to plug -2 in, so I'm going to erase that because that's not required. If you have it, just cross it out. And then you're going to plug in 0. Guys, am I going to use this equation or this equation? The top one. You guys good with that? The most common wrong thing to do, and I do it wrong too, is to use f prime instead of f, okay? F prime is actually for first derivatives test, okay? For the absolute maximum and for the candidates test, use f. If you don't use f, you're going to make an f. Does that make sense? Okay? So go ahead and choose your f, all right? So guys, when you put in 0 here, do you see you get 0 minus 0, which is 0? You guys good with that? Okay, I'm going to cross this out just so I don't accidentally use it. If I put a 2 here, I'll get 8 minus 24, which is negative 16. And if I put a 4 in here, I'll get 64 minus 48, which, 64 minus 48, what do you got, 16? Is that right, guys? Okay, 16. Now, guys, I need to choose the absolute max and the absolute min. Where's my biggest value? 416. So I'm going to go ahead and circle that. You don't have to circle it, but it's useful for me. I'll say absolute max at 416. Where's my absolute min here?
We don't need it.
Yeah, you don't need it, but where is it just in case? Yeah, 2, negative 16. So that's my absolute min. Okay, guys, look at the question. The question is, find the maximum value. Okay, and I got to tell you, just because AP is mean, I'm mean too. Okay, and on your test, this is going to be a multiple choice question. And you guys are going to be like, yay, multiple choice. Okay, well, the bad thing about multiple choice is that it has every single possible wrong answer in it. Okay, and so if you're not looking carefully, you're probably going to choose the wrong answer. Okay, so can someone tell me, what is the maximum value of this function? E or D or C? Okay, you guys are good, okay? I can't trick you guys. But guys, I can't tell you how many students I trick on the test, okay? So make sure you understand, you're pulling the Y value, or the Y minimum value or Y maximum value, depending on what I'm asking, okay? Yeah, Charles?
So for when there's like 2 maximum values or there's like 2 peaks?
Yes, it's still the same, right?
So those are...
It's still maximum values. There's 2 maximum values. And it'll still be the same number, right? Because they'll be equal.
Okay.
Yeah, so it'll still be the highest number. All right. Okay, make sure you know that. Guys, this problem here, I'm going to leave online with the solution. I just want to tell you, students miss this on the test. The reason students miss this on the test is because when they do implicit differentiation, hopefully you know how to do it, is when you differentiate right here, please change this before you differentiate it. Please change it to this problem. Why? Because then you can make this your first, this is a product rule, and this your second, and your negatives are going to work themselves out, okay? And you just add every part together, right? Remember, you thought you got to do one problem, but oh boy, you get to do 3, okay? And don't forget, the derivative of 16 is what?
0.
0, okay? So make sure you do this. I'm not 100% sure. I think this might be a multiple choice question on the test too, but I gotta promise you, I do it every wrong way that students do it, okay? And every wrong multiple choice is there, okay? So make sure that you do it correctly, and I'll put this online. And you guys should be practicing without the solution and then checking your work, okay? And that's the best way to practice. All right. Just so we have enough time, guys, I'm going to go over I know you guys have homework questions, but I'm going to go over the first derivatives test first, and then we'll go back and do homework questions and check your homework, all right? So let's go over first derivatives test first. All right. The first thing I need to tell you guys about first derivatives test is it answers 2 types of questions, okay? The first derivative test answers the question is, what is your relative max and what is your relative min? Okay, if you're trying to find that, you're going to use the first derivatives test. The second question that it could answer is, what is your interval where f is increasing? And where is your interval where f is decreasing? Okay, so if you have any of these questions, you're going to use what's called the first derivatives test, okay? And that's what we're going to talk about today. Now, if they ask you for what is your absolute maximum, what is your absolute minimum, what test are you going to use? Your candidates test. Does that make sense? That's the candidates test. We just did that one, okay? Don't get that confused with the first derivatives test, which answers these other questions. And we need to know a little bit of something before we start this test. And what you need to know is this. If I have a function, and let's just say it's a parabola, and it looks something like this, okay? I can tell you some things about the slope, okay, just looking at this problem. If this is, I'm going to label this my f. This is my f function, okay? I can actually tell you some things about the slope. I can tell you, let me make this value 0, that when x is less than 0, my slope is always positive. Do you agree with that? Okay, I can tell you that. So what we learn about the derivatives test, which is useful, is that when f prime is positive, if your slope is positive, then that means your f was increasing. What does increasing mean? Increasing means when I take my finger and I go from left to right, I'm going uphill. Guys, you got to go from left to right, okay? I have students who go, wait, it's decreasing, because watch, look, going downhill. No. You go from left to right, okay, to say it's increasing. All right. Then the other thing I can tell you is my slope on this side is always negative. Do you agree with that?
Yeah.
Always, okay? I mean, put your hand up to it. Get your coffee stirrer. Those of you guys who took your tangent lines home, okay? Put your tangent lines there. You'll see that the slope is always negative. So the first derivatives test tells me when f prime is negative, then f is always decreasing. Always. These are absolutes, okay? Now, the other thing that's kind of interesting is that when f changes from increasing to decreasing, you always have a special thing there. You always have a relative max, okay? So that's what I'll put on this side. If you ever change from this row to this row, f has a relative max. It just does, okay? And guys, what if I loop this thing back up? What if I brought this back up, okay? If f changes, do you agree f is decreasing here? If f changes from decreasing to increasing, what do you have that happens right here at that very point that it changes? It's a relative min. So over here, I'm going to put relative min, okay? Relative min. And I call this the first derivatives test water cycle, okay? Has nothing to do with the water cycle. You will not find that in any book. You're welcome, okay? This right here is what you need to memorize. It's going to be very, very helpful. So let me show you why this is helpful. Okay, so let me show you the first derivatives test, okay? This looks very confusing, I know, but it's actually just verbally what we just talked about. When f prime is positive, f is increasing. Isn't that what I said here? When f prime is positive, f is increasing, okay? When f prime is negative, so remember you can also say less than 0, f is decreasing. Isn't that what I said here? F prime is negative, f is decreasing, okay? When you move from one row to the other, you either have f as a relative min or f has a relative max. I ran out of room there. that this would be x is a relative max. If you move from the top row to the bottom row, a relative max is going to form. If you move from the bottom row to the top row, a relative min is going to form. So when do you use a first derivatives test? Two situations: when you're trying to find the relative max or relative min, or when you're trying to find which intervals are decreasing or increasing. Okay? And you use that by finding critical numbers. Because we talked about this before, right? Our critical numbers are where I have humps and valleys, right? Relative maxes and mins. We did that in absolute maxes and mins. So let me show you how to do a problem like this. And when I show you, you'll be like, oh, I get it. That's so easy. Okay. So if you had a problem like this and I said, hey, tell me the relative max or relative mins, or if I said, tell me where you have f increasing or f decreasing, what you would do is you would first do the derivative. Okay, you would take the derivative first of the function. Okay, you're going to go find the critical points because that's where your relative maxes and mins are. So you're going to set the derivative equal to 0, and you're going to set the derivative equal to 1 over 0. Remember, that's your critical points. How do you find critical points? Set your derivative equal to 0 and set your derivative equal to d and e. All right? On my left side, do you see you're going to get x equal to negative 4? Okay? On my right side, as long as you have no fractions, okay, you got to be careful though, then what you get is 1 equal to 0, and you're just going to get no critical points. Okay, if I were asking you for absolute max and min, you would take your critical points, you would take your endpoints, notice I didn't even give you endpoints here, but that you would take your critical points, you would take your endpoints, and you put them into what kind of test? A candidate test, right? They're not asking for absolute max and min here though, they're asking you for relative max and min. So what you do, instead of taking your critical points and putting it into a candidate test, you're going to take your critical points and put them in what we call an f prime number line. Okay? On this f prime number line, you're going to try to figure out where f prime is positive and where f prime is negative. Why is that useful? Because when f prime is positive, what do you know about f? F is increasing. When f prime is negative, what do you know about f? F is decreasing. Okay? So what I'm going to do is go find f prime. So do you see f prime is right here? Okay. Then I'm going to find some numbers in this interval. So what's a good number to the left of negative 4? Negative 5. I'm going to test it into here, and I'm just going to find out if f prime is negative or positive. So if I put negative 5 into my f prime, do you see that would be negative 10 plus 8, which is negative. Now you don't need to know if it's the number of value. You just need to know if it's positive or negative. So anytime I plug a number less than negative 4, I'm going to get a negative f prime. So I put that into this f prime number line. Okay, I also need to find a number that's on this interval bigger than negative 4. So what's the number bigger than negative 4? You can choose any number. 0 is a great number. If you chose negative 3, that would have been a great number too. Okay, if I plug in 0 into f prime, make sure you're not plugging into f, right? This is an f prime number line. Guys, I cannot tell you how many students don't label this number line and end up plugging into f. Okay, that would be wrong. You got to plug it into f prime, put in 0. Do I get a positive number or a negative number? Okay, positive. So what you're going to do is say positive. Well, remember what we learned. When f prime is positive, f is increasing. When f prime is negative, f is decreasing. So what you're going to do is you're going to draw your f's here. This is a picture of your f. The number line is a picture of your f prime. Okay? The pictures, f increasing and decreasing, is a picture of my f. So guys, if I drew my f, do you see f looks like that? Like if I connected it together? So what do I know about f? Let's think about all the questions that they've asked me. The first question is, when am I increasing and when am I decreasing? Do you see f is increasing at x greater than negative 4, and f is decreasing at x less than negative 4. And there's my answer for intervals of increase and intervals of decreasing. Does that make sense? You just look at this picture, right? There's my picture. All right? And the other thing they're asking you is, where is any relative max or min? Do you have a relative max or min? You do. So you'll say there's a relative min at, and get this point. Well, it's at x equals negative 4. Make sure you understand all these numbers you put down here are x numbers. Okay? What's your y number? If I know my x number, do I know my y number? Yeah, you just plug it into this right here. So what you'll get is, I'm going to do f of negative 4 That's going to be 16 minus 32 plus 10, 26. Is that negative 6? I'm not 100% sure, but you guys might be. Is it negative 6? 32, 26. Yeah, negative 6. Everybody good with that? So there is my relative min. Are you guys good with that? Okay, let's do another problem. All your problems are basically like this. So if we look at this problem here, okay, we're asked the same question. You're given f. Can you please tell me where your relative max is, where your relative min is, and where do you have f increasing and where do you have f decreasing? Guys, what do you do first? If you have no idea what to do, what do you do first? Take the derivative, okay? When you take the derivative, what you'll get is, you're going to find your critical points. So you get 3x squared minus 12x, and you're going to set it equal to 0 or d and e. Is everybody good on why I'm setting equal to 0 or d and e? I'm setting f prime equal to 0 and d and e. What points do I get when I set f prime equal to 0 d and e? My critical points. I'm trying to find my relative max and min. They always occur at critical points. Okay, now I'm going to solve on this side, so I'm going to pull out a 3x, so I'll get x minus 4 is equal to 0. So x is going to be 0 or x is going to be 4 on this side. On this side, I have no fractions, so I'm going to cross multiply. And what happens here is I get no critical points. Okay, if I were trying to find an absolute maximum, I would take my critical points and my endpoints, I would put it into what? A candidate's test. I'm not trying to find absolute maximums though, guys. I'm trying to find relative maximums. So what am I going to do instead of a candidate's test? An f prime number line, okay? So draw an f prime number line and put all your critical points there. And make sure you understand, these are actually x values, okay? I'm going to put in all my x values where f prime is equal to 0 or d and e. Then I'm going to test the interval. So I'm going to find a good point there, a good point between 0 and 4, and a good point greater than 4. What's a good point less than 0? Negative 1. What's a good point between 0 and 4? 1. What's a good point greater than 4? 212. Okay, so then what you're going to do is you're going to go to your f prime. Is everybody good not going to your f? Go to your f prime. Here's my f. Oops, I labeled it wrong. Sorry. Here's my f prime. And guys, you can actually use this one. This one's actually easier. Right? Isn't this the exact same thing as that?
Yes.
Okay. So go ahead and plug in negative 1. If I plug in negative 1, I just need to know positive or negative. Okay, hold on, Brad. So plug in negative 1. Do you see that would be negative 3 times negative 5? Positive or negative? That's all I need to know. Negative times a negative, positive. Okay? That would be f is increasing, right? How do I know that? Because when f prime is positive, f is increasing. All right, let me figure out if I plug in a 1. Is f prime negative or positive? Put in 1 here. That'll be 3 times negative 3. Positive or negative? That's all I need to know. Positive or negative? 3 times negative 3.
Negative.
Negative. So do you guys see that would be f is going down, decreasing. Why? Because when f prime is negative, f is decreasing. Hopefully you have this somewhere on your paper. Okay? Let me put in 212. If I put in 212 here, positive or negative? Positive. If I put in 212 here, positive or negative? What's a positive times a positive? Positive. So I'm going to get a positive here, and that means f is increasing. Guys, be careful. A lot of times for polynomials, we get positive, negative, positive, but it's not always true. Okay, it's not always true. So don't just think it's always alternating. Okay, you actually need to figure it out. And so if I drew my f, do you see? It would look something like that. Okay, so tell me, looking at this picture, when is f increasing? At where? At where? When x is less than 0, or when x is what? Greater than 4. And some students ask me, should you put an equal sign in there or not? I don't care. AP doesn't care. I don't care. It's actually a controversial thing among mathematicians if you should put an equal sign there or not. So don't worry about it. If you put one, it's great. If you don't, you're still great. Okay?
Yay.
What about f is decreasing? Where is f decreasing? Between 0 and 4. Okay? What about, is there a relative max anywhere? Yeah. At what x value? 0. At what y value? If x is 0, what is your y value? 15. There's your relative max. You see how I'm getting that? How do I get my relative min? Where is it at x equals what? 4, right? Do you guys see there's a relative min drawn here? Okay. Well, at 4 what? How do I get my y value here? You see you just put 4 there, 4 there, 4 there. And so this value here, I know you think I'm going to tell you, but I have no idea what it is. So just put in f of 4, whatever that number is, okay? You guys can figure that out. You can do it. I know you can, okay? All right, so that is how you do these problems. Any questions about first derivative test? Pretty easy, right, Brent?
This isn't on our test on Wednesday, right?
It is on your test on Wednesday, so I hope you're paying attention. So it is on your test on Wednesday, but tomorrow's material is not on your test on Wednesday. So Miriam.
But you said rolls isn't?
Rolls is not though. Okay, rolls is not. Yes.
So if you don't know the number, like, you know how you just put F4 is it okay for zero?
No, you have to actually put the number in. No, but it depends. It depends on my question, because sometimes I'll say, at what x value is the relative min? And then you'd be like, oh, just 4. But if I said, at what point is the relative min, then you need both. Okay, then you have to calculate. So it depends on the question. Okay? All right, guys. Please pull your homework out. We don't have time to look at homework, but I'd like to go ahead and check your homework. All right? There's a slide here, and I didn't have time to discuss it in first and second period, so I'll just leave it up here for you guys, and I'll talk about it tomorrow. But it's about what's on your test. Okay? And I will post that also. Please have your homework.